everyone, and welcome to Intro to iOS Lecture 1. I will be one of your course instructors along with Gonzalo, and we'll be teaching this course for the semester. And so just a brief overview, we'll have an introduction about us, some logistics, the actual frameworks and tools we use to create iOS apps, a small demo to help you get familiar with Swift, and also like the syntax you'll need on your first project and also like all your projects, and then some action items for you to do. And so starting off with introductions, I'm Yan Lum. I'm a junior studying CS and one of the course instructors. And so I've been on app dev for almost 5 semesters now. I joined my freshman spring, and I've worked on Uplift and CourseGrab iOS before, but I've also dabbled in a bit of Android and web. So this semester I'm not on a pod, I'm actually doing a co-op, but that's enough about me. I'm going to hit up Gonzalo.
Hi everyone, I'm the other course instructor. My name is Gonzalo, I'm a junior doing CS, and this is my 5th semester on AppDev. I am currently working on Pair, and I'm doing backend work because I recently switched to the backend subteam. But before I switched, I was on the iOS team for 3 semesters. I took the course in my freshman fall, and I was able to join the team in my freshman spring. And one of the first things I was assigned to was actually eatery. If you remember, eatery used to have campus and college town eateries. I was part of the effort to help with making the college town section, but that was taken down because no one was really using it. And then my second semester, I was also working on eatery, but I transitioned to working on active announcements, which isn't one of our apps. It's actually something that you'll learn about later on in the course. It's a third-party library, and we call those Cocoa Pods on iOS. And the purpose of it is we have basically in-app notifications. Whenever you open your app, you'll see a pop-up, and we can use this Cocoa Pod on any of our apps. So it's very useful, and it helps us transmit information to anyone using our app. And on my third semester, I was working on Polo, which is or was supposed to be a free iClicker replacement. But because of the pandemic, there have been so many polling options that have been released that it wasn't very feasible to keep working on it. So we scrapped it. And on my fourth semester, that's actually when I switched over to backend. And I was doing some iOS work on Polo too during that transition. So yeah, I'm here on the backend subteam, but teaching iOS because I want to show all of you what I've learned on AppDev. And now let's talk about our course staff.
All right, so now just to introduce our course staff, these are the people who we'll be working with, and they're really dedicated to helping you and helping everyone be able to succeed. And so just feel free to reach out to any of them if you need help. And of course, you guys have all been assigned like a direct TA mentor to work with. And so if you're more inclined to reach out to them, feel free to reach out to them as well. Yeah, so now for course logistics. All lectures will be put on our YouTube channel, Cornell App Dev, 7:30 p.m. Eastern Time on Mondays. We'll try to get around there, but obviously it won't always upload the exact time. We'll be using Slack for all course communication. So if you haven't been added to our Slack, you should email courses@cornellappdev.com to get yourself added. Course textbook, we have that. We'll link it in the Slack channel. We'll also link our OH Google Calendar in the Slack channel. And we're going to be trying to use DTI's Cue Me In for office hours this semester, just so everyone can hop in and hop off whenever they need to. And projects are due Sunday. There's one drop excluding the first project and the final Hack Challenge project. And the deadline to submit is on Sundays naturally, but if you're going to submit late, that would be on Wednesday with a 1-point penalty per day up to a max of 2 points. And obviously academic integrity, make sure you're not copying people's code or sharing your code with others, because we have to pursue these cases and these cases will be reported. And so with a lot of programming projects, you might have to search things up on the internet every once in a while. And we do ask that if you're using Stack Overflow or whatever other sources are out there, please do link as like a comment or something in your code to your sources. And so for enrollment, the deadline to add this course is March 15th. The apps close February 26th. And this is actually different from Cornell's add deadline for 7 week 2 courses. And we do ask that you do add this course by then. This is a hard deadline, and that's because our lectures have already started and it'll be hard to catch up if we wait too long. And so yeah, enroll in CS 1998, section 601 for 2 credits SU, and make sure that's 2 credits because you could potentially select other credit amounts. However, 2 credits is like what this course is going for. So some brief like requirements. Obviously, these aren't hard requirements. They're kind of flexible and you can learn on the spot, but we generally do want to have students with some kind of intro programming courses taken or just like the knowledge there, which will make things easier. And you do need to have a Mac OS or a VM to run Xcode, which is where all the projects will be done in. And yeah, so how do you make iOS apps? Swift is what we use to make iOS apps. It's a simple, fast, expressive, and safe language, and really, really neat and clean. And for iOS and macOS, there are actually 2 languages that are primarily used to develop them, and those are Swift and Objective-C. However, Swift is just more flexible and clean, unlike Objective-C, where you have to specify your types, you have to have your colons, and it's just a very strongly typed language. And so Swift is what we'll be using in this class and what we'll be learning. And so just yeah, with Swift, we have Xcode, and Xcode is the actual tool that is able to build and run these apps. And you'll be able to see on the simulator what you have coded. And so that's always fascinating to see. But yeah, let's just move on to now the actual demo of Swift and the syntax we'll be using. All right, let's get started. So with our playground, if we go to Xcode, File, New Playground is how you can make a new playground. And so what it is kind of like a text editor like VS Code or Atom, except you can't run apps, but you can play around with Swift code. And so just like an overview of what a playground interface has. Down here is where any errors or print statements will show up. And we have the code in this main area with our imports at the top. So if we want to import external libraries or code bases from elsewhere, like a UI kit, which we'll be extensively using in our apps, then we import them likewise. So for constants and variables, let and var, these vary differently, with let being immutable and var being mutable. So the let constant, if we try to change it, net ID equals to ABC123, then we'll see here that we can't assign value net ID because it is a let constant. And we can do this with current year because that is a variable, a var of our variable. So type annotations. So in Swift, types are implicitly typed, and so if you have a string here, then Swift will be able to understand that netID is of type string. However, if you want to strongly define this, you can use the colon syntax here, where we have full name colon string yamamko. And so if we try to assign a different type to the variable full name equals to 1, then we'll see here that Swift will complain because 1 is an int, but full name is strongly typed as a string. And so this is also where we see imports coming into play, because if we comment out our import, when we run this, we'll see that we can't find UI label in scope anymore because UI label is part of the UI kit. Yeah, so with printing strings and variables, this is very similar to other languages. You just print string this way, or you can also print with interpolation. So something to note is that if we do try to concatenate with a plus, we'll see that you have to cast your values to a string in order for that to work. So we do like to see the string interpolation used more than concatenation, just because it's just a cleaner syntax to use and it doesn't require casting. All right, so next up is arrays. There are many ways of initializing arrays in Swift. And so the ones you see here are through the constructor, where you're having like an int array and in the open and close parentheses to initialize an empty one. And the second one being the type declaration, where you're setting the type to be an int array and then just initializing it to the empty array value. And something to note here, that arrays do need to be explicitly typed if they are empty. So we have something like var lecture numbers equals to the empty array and try to play that, then Swift will complain here because it's empty and we don't know what element should be able to go in there. However, if we pre-fill them to something with ints, lecture number 3, there we go, then it's okay, because Swift can implicitly recognize the type to be an int array. And so all elements must match the array type. So if we uncomment these lines, we'll see here that the first line works because 1 is an int. However, the second line with a string, we cannot convert that type for the int array. And so let's uncomment that there. And so for loops with arrays. So there are many different ways to do for loops, or just loops in general. We can work through ranges, which are the first 2 examples here, and we can also iterate through arrays, which are these 3rd and 4th examples here. And so the first loop goes through numbers 1 through 9 because of this less than, and the second one is inclusive of all 10 numbers. So if we just play this, we'll see here that we print the first 9 numbers and then we print the 10 numbers. And so let's comment that out again. So removing from an array can remove it via index. If we play that line, we'll see here that we've removed the 1 from the array because it was at index 0. Yeah, so if we try to remove from an empty array or an index that isn't within the array, then we'll see here that there's an index out of range error. All right. So then we can also modify an array by indexing. So if we have our current course instructors, Lucy and Matthew, and then we replace them with me and Gonzalo with the 0 and 1 indices, we'll see here that it was changed to me and Gonzalo. All right, so I'll just comment that out and we're back to Lucy and Matthew. And so that's how you can update an array. And so if we try to set something that's outside of the range, then we'll get index out of range again. And if we're trying to just add to the end without specifying an index, we can do that with the append. Let's print course instructors here. And we can also add with a dot insert. And so the dot insert just allows us to insert it at a different indice than the end of the array. All right, so dictionaries. Dictionaries are very similar to arrays in the sense that they need to be explicitly typed if you have an empty dictionary. So these are also very similar to Python dictionaries and Java hash maps, but if you don't know either of them, then just think of a regular dictionary where you have a word being the key and its definition being the value. And so here we see we have two types, string and int, with a colon splitting them apart. So whatever is to the left is the keys type. So the keys are strings in this case, and whatever is to the right of the colon is the value type. So the values are ints in this case. So you can add and modify a key value binding using this syntax where you're accessing the key and setting it equal to a value. And we see here, if we actually try to print a value before it is set, then it will show up as nil. And this is saying that the value doesn't exist. And so we can also create a dictionary and fill it in this way where we just separate all the key value bindings with commas, and we can also iterate over the different key value pairs with a for loop tuple. And so here we have 2 chocolate bars, 10 apples, and 5 oranges. And something to note here is that unlike arrays, which are ordered, dictionaries don't have an order. And so you can't always count on the order you define your key value bindings in to also be iterated through in a for loop. All right, so next up are functions. So functions are just a simple way of factoring out and reusing code. So our first one is pretty basic. It doesn't have any arguments and it just prints something. So if we call it over here, then it'll print something. And so we can also have a function with arguments. In this case, we have 2 arguments, the first one being an integer and the second one also being an integer. And so this arrow in here is just telling the function that our return type will also be an integer. And so we can add 2 numbers with this. And if we uncomment the print statement, we'll see here that we add 2 and 3 for 5, or we can also add 3 and 4 for 7. And something pretty cool is that you can set default values for inputs to a function. So if we want to print add without any arguments, then it'll print 0 because it will default A and B to zeros. All right, so now for structs and classes. So structs and classes are very important when it comes to creating objects in Swift. And so structs and classes both have properties that we see here. And the main difference is that classes are reference objects while structs are value objects, and classes do require an initializer to be created. And this initializer doesn't always have to include all the properties within its input, and it can just like default one of its properties to something like the empty array, and thus it wouldn't need an input. However, for structs, you'll have to override all of the properties when you're creating an object for it. Yeah, so we'll see here that we don't have a function in our struct, but we can create one and say play episode. This episode is sponsored by name. All right, so yeah, both of them can have functions, but it's only the class that needs to have the initializer. And so if we create an instance of the class, we'll see that we're having the input for name and episodes because that's what's in the init. If we just completely delete episodes here, we can have that be the empty array and just play that there. And there will be no errors. However, for the struct, if we try to get rid of one of the inputs, then we'll see that we're missing an argument because structs need, well, structs need like all of its properties to be overridden. There we go. All right, so accessing properties, we can just use the dot notation, and that'll just let it access the different properties in it, the duration and name, and we can also access its functions same way. Yeah, so like I said before, value types versus reference types. Structs are value type while classes are reference types, and this means that if we're creating a struct for episode 3 and we're setting episode 4 equal to episode 3, then we'll see here that by changing episode 4's duration, we only change its duration and not episode 3 because they are separate objects. And however, for classes, if we have podcast 2 and podcast 3 and we change podcast 3's name, then we'll see that podcast 2's name is also changed. And this is because the podcast 2 and podcast 3 variables are reference pointers, so they're pointing to the same object in memory. However, episode 3 and episode 4 are separate objects. All right, so next up are optionals. So optionals are a way to specify if a variable can have a value or not. And so here we see that input string is just a string, but optional string has this question mark right after its type. And this just specifies that optional string can either have a value of a string or nil, which is kind of like none in Python or null in Java. And so you see here that if we try to assign nil to input string, then we get an error because string is not an optional. However, optional string, where the string type has the question mark after it, it is an optional, and thus there won't be an error if you set it to nil. So for unwrapping optionals, we know that the optional string can either have a string value in it or no value at all. And so we can't just print it without unwrapping it. And so let's try to set it to hello. And we see here that the optional string will be actually wrapped in a optional object. So this is kind of unelegant because we're just checking if optional string is nil or not, and then having that in the print statement. But there is a special syntax for Swift called the if-let statement, which basically, if you set some variable if-let equal to the optional string, then it'll take whatever is inside the optional wrapper and place it inside unwrapped strings. So here it actually checks if optional string is nil or not. If it's not, then it'll execute whatever is inside the if-let statement. Otherwise, it'll just pass through it. So we see here that the unwrapped string is hello world, but if we change it to nil, then we don't get anything. And so we can also chain the if-let statements and unwrap like multiple optional values within the same if-let. So here we have some string and 4. And so another way to unwrap optionals is through guardlet. And this is kind of different because we're prioritizing the else statement instead of the if statement. And so instead of trying to define what should happen if there is a value inside the optional, we're now defining what should happen if there is a nil inside the optional value. So here we have guardlet, and then inside the else, we just return because unwrapped string, or optional string is nil, and so we weren't able to unwrap a string from it. But then if it's able to unwrap a string, then we can use that variable down here. And so let's try printing that. We see that here, guardlet returns the function because the optional string is nil. However, if we try that, we can unwrap hello world from the optional string. All right, so we can actually give optionals a default value with question. And so here we have an unwrapped string with default value, and this is not an optional variable. However, it's using an optional string, which is an optional variable, in order to set it. And so if it does turn out to be nil, then it'll just default to this default string here. So let's just play this, and we'll see that the print unwrapped string was nil, was executed. So if we set optional string to something like hello, then we'll see that the unwrapped string value is hello. And so this print statement is executed instead because optional string is no longer nil here. And so because unwrapped string with default value is not an optional, we can just print it clearly without any unwrapping. And yeah, so another way of unwrapping optionals is by force unwrapping. And so this is fine if you know a value exists, like here where we have hello world, we know that the string is there and it's not a nil value, so we can force unwrap it. However, it can be dangerous in some cases where the string is nil and then we try to unwrap it with the exclamation point, and we get that fatal error because it was nil. So if you're unwrapping optionals, your best bet should be if, let, and guard statements. So back to dictionaries. So dictionaries, as I mentioned before, they have key value bindings, and when they're empty or just initialized in the first place, all the values don't exist. So if you try to access a value with its key and the value hasn't been set yet, the value will be nil. And so if we try to play if let value equals pantry pairs, we see here that nothing prints because pantry pairs is nil. But yeah, if we set pantry pairs to 1, and when we try to play that again, we'll see here that we have 1 pair. And that's because the value is no longer nil. Yeah, and then let's try apples. Well, apples was set previously, so we have 4 apples. Okay, so lastly we have enums and case statements. Enums are a way to specify values that are limited. So here we have font size, case, small, medium, large, and there are just different ways you can create it. And so here we have the small, medium, large, and because we are giving the variable large font size, the type font size here, you see that we can just click on the dot and be able to scroll through the different options that the enum contains. And so for switch statements, this kind of just iterates through the different cases that an enum can have, small, medium, or large. And so the default here is saying that if the case isn't met within and it's something else, then we'll just execute whatever is within the default. So let's try printing large font size. And so we see that I don't know is printed because we don't have a case for dot large. And so if we actually delete the default statement here, then we see that this switch must be exhaustive. And this is because we need to make sure that all cases are met. And we can actually just add a case here for large and print I am large. And so in this case, we see that default will never be executed because all the cases have been exhausted. And so we get a warning for that, but it will still compile. And yeah. So lastly, we have some action items to do ASAP. Pretty much make sure you're enrolled. CS 1998 section 601 with Walker White should be the course you're enrolled in, and make sure that you are in our Slack. You should be in our Slack, but if not, email courses@cornellaptiv.com to be added. And yeah, so project 1 handout is in the course textbook, and we'll link the course textbook in our Slack channel, and that's due this upcoming Sunday at 11:59 p.m. Eastern Time on CMS. And you should also have been added to CMS. So if you haven't, email us. Thank you. Or Slack us if you're in the Slack. Thank you.